Okay, next up on the stage is ProProject. All right, and I know that
I gave you my.
yeah, I think I've got.
It's in PowerPoint. I gave you from this stick.
Let me bring up PowerPoint, and then we'll get you started.
Maybe I will start already talking. Hello, my name is Rafał Kartaszyński. I represent a small family business from Poland. During this presentation, I will show you. Okay, it's working. In my presentation, I will show you how we guarantee accurate diagnostics for busy hospitals. But let me start with some sad numbers. According to data from insurance companies in 2017, total amount of malpractice payouts reached astonishing number of $4 billion. 34% of these cases was related to misdiagnosis, something went wrong in the diagnostic process. 50% of these cases involve death or major permanent injury. Medical claim was paid out every 40 minutes. Imagine for a moment chances that you or your loved one are involved in a similar case. Fortunately, this can be changed. Fortunately, there are our unmatched solutions for quality control, but combined software and hardware we develop in-house. But let me tell you how it works. Basically, everything comes down to a patient substitution method. So you, instead of taking X-ray of a patient, you X-ray phantom. So as a result, you get an image of what is inside the phantom. Then on this image, you have to look for different features, analyze this image to get to know what the device is showing. So, for example, if mammography unit will miss small tumor in the breast. Traditionally, this process is performed by highly qualified personnel, so medical physicists, for example, in the hospital, and it takes a lot of time because it's not only like an image acquisition that I showed you, it's also a lot of analyzing of images because you have to go into details and you have to do everything by hand. Here comes in our innovative computer vision software, but automatizes the process, making it easy, more reliable because it's not subject to human bias. Also, it's reducing costs, time, so the specialists can spend their time not on quality assurance but on treating patients, which is more important. Great example of how powerful our solution is our case with Siemens in Poland, using only four kits of the Phantom I showed you before, and our software, we are able to reduce the downtime of units, C-arms in this case, from 3 to 4 days to astonishing 1 hour. So something that took like team of specialists and like many days to measure, to analyze, to prepare reports, now can be done by one service guy in 1 hour. And it was done for the entire country of Poland. As you can see, only this shows you that we provide best innovation of the market. We also provide best offer on the market currently because we have largest spectrum of products. We are the only company on the global market that has so many ISO standards. We are also the best technologies in our house because we can simultaneously produce a wide range of objects, pinholes, or cameras, or gold discs for mammography. We are the only company that houses all these things in one place. Thanks to this, thanks to our innovative approach, not only to products, but also to people, the market, only since 2011, we managed to acquire distributors in over 110 countries. We are already present in the US. US already trusts us. Our products for mammography are the only products that are accredited by American College of Radiology. Only only company that has this accreditation from outside the US. We also cooperate with Fluke. You may know this is one of the largest companies in the world. I will tell you more about our market later during the questions because I think our time is running out. Yeah, so I want to show you that US for now is like our fourth market. And so China is like 3 times bigger for us. And I want the US because I'm personally involved in US as well because I'm a resident here. I want the US to be here, on the top, the main market, And I want to show you more about our team, but I will show you a photo of our distributors from our first international distributor meeting. 50 guys from all over the world came to Poland just to meet us, even from Australia. What are our plans for Nevada? We are aiming into 3 directions. We have like modality providers like Philips, GE, Siemens, service companies that are servicing X-ray equipment. And we want to repeat the Siemens story with them. Do this in the US market. Show this on the living system. We want to show them that what is possible because if you have a car, you have this like a cam. You can put a computer to the car and you have everything about this car. But you don't have such things with X-rays. The manufacturers don't have any history, any records of how the device is performing over time. And we can provide it. And this is like a huge market, only for like Siemens or GE. We also want to work with end clients, so like install a solution in hospitals, clinics, universities to show how we improve, how we reduce costs, how we reduce downtime, how we improve the quality, and how we reduce medical claims in the result. And so we want to set up a reference site in Nevada to show that Nevada is a place where the diagnostic quality was revolutionary.
Okay.
Thank you.
Okay, let's start in the room with questions.
So you went through that slide on the different modality that you're focusing really fast. Can you just go through currently what modality you can actually use your technique?
This is our strength because we do everything. Dentistry, radiography, fluoroscopy, mammography, ultrasound, CT, MRI, nuclear medicine, radiotherapy. So we go like complete diagnostics. And this is like thanks to this approach, like wide approach, our offer, we have like only one competitor in the world. Because only one company in the world is going so global. And we are, I think after last year, we are larger than them.
And the second question is, machine learning and pattern recognition for imaging analysis is a fast-moving technology. How do you see your technology eventually to either take advantage of the AI and machine learning for imaging diagnosis or integrate with it?
Yeah, we plan to do it, but on the later stage. You must know that the market we are on is very stale. It's these are people that are working like this since like 30 years back, and to convince them to use like an online solution, it's a challenge. If I tell them that okay, it's AI involved, oh my God, it's something typical. That's why I want to set up this reference site to show people that this can be done better. It's not only like transactional sale. It's a way of thinking, way of doing QA in a better way. And after that, of course, AI is a natural step.
And Paul, will they have a chance to go and talk to UNR Medical School in Renown?
Yeah, we are going to.
For people that opt into this, is there potential for malpractice, a shift of liability, saying, if it's misdiagnosis coming into this, they're using this, can that potentially shift malpractice liability to you as a provider of the service?
We are only like providing assistance. So still, the medical physicist, the technician, he bears responsibility. We can only help him, to do his job quicker. Of course, in all QA process, we always do validation. So I imagine that like each year they would validate if everything is working okay. but it's like QA process. You also have to test devices each year, for example, or each month. So it's like it's more on the, we always provide tools, and it is up to the user to use it properly and to make sense of the results.
So I just want to understand your product better. So your product is essentially software that analyzes the results of the phantom target to calibrate the equipment. Is that fair enough? Or are you making the phantoms as well?
This because it's difficult to I will show you something. This is, for example, phantom. This is a very simple phantom. I will show it to you. It's a resolution pattern for checking what is the resolution of an X-ray.
Right.
Device. So you make exposure of this, and on the image you will see the lines, and this way you can check what's the resolution. And our main market is hardware.
So you're making the phantoms.
Yeah, we are making the phantoms, and this distinguishes us from other companies that are making phantoms because we are also making software in-house. Everybody else is like, okay, we are a phantom company and we will buy software from somebody else. And it doesn't work very well if you have somebody sells software. But we have like everything in-house. We have this know-how, this idea of doing the QA in a simpler, better way.
Okay, thanks. I have a long ago background in medical physics. I'm familiar with calibrating the equipment.
Yeah.
So I'm gonna.
So this looks familiar, I think, for you.
This is your patient substitution.
Yeah, exactly.
All right, so I'm going to go online really quick to see if there's any questions from the folks online.
I'm good.
Okay, and Maggie's not chiming in, so we're back in the room for our final. We got about 4 or 5 minutes left.
So are you thinking about taking this, one of the challenges of kind of personal health and precision medicine is, calibration of wearables and things like that. Are you imagining an extrapolation where, there's some sort of periodic check-in so that there can be synchrony and calibration of some of these?
I don't have to imagine. It's a law. For example, if ACA showed you, but ACA has a program that accredits. They have accreditation for mammography units. And if you have you are a hospital, you have mammography unit, you want to get funding from the government, you have to participate in accreditation program of ACR. So then you have to have phantoms, you have to do the QA. So this is like a QA is already being done, but it's, for me, this tool that sells a lot in the US is very simple, it's very crude. Our idea is to have larger phantom, but measures not only resolution, only this simple thing, but a lot more. So like density. So is it like a bone? Is it like a lung, or is it like a liver? So we measure a lot more. We want to make this, make people understand that this is not something difficult. Because, for example, I know this also a fact in the US, but people don't like to do QA because it's time consuming. They usually just copy the results from last year or last month. So it's not very wise quality.
Right, but you can, imaging is one thing, but anything that we're sort of measuring its health and it has a certain amount of subjectivity for the patient, as well as ranges that can be a little bit dangerous.
Yeah.
Osteoporosis, bone density.
Yeah.
There are people walking around
Yeah.
to break a hip. There could, you certainly have concepts around being able to calibrate that. So I guess the question is, are you thinking about taking that calibration down to sort of a personal device level, or are you really just thinking about the big machines in the medical center?
Mostly we do with imaging devices, so CTs, MRIs, C-arms, small dental X-rays, and this is what we focus. So we ensure quality of image, not the dose, if you get the correct dose during the procedure, but if the image that device produces is of diagnostic quality. But if you go for mammography, it won't miss this small tumor in the breast, and you know it will save your life.
Big machines in the medical
Yeah.
center. That's okay.
Yeah.
It was just an answer.
Yeah.
We have about a minute and a half left, so we got time for one more question.